All right, hi everybody. I wanted to make a video that shows you how to perform a multiple regression using JASP. Don't need to actually do a multiple regression in JASP for your homework that is due in week 2 on Thursday, but you do need to interpret the output from a multiple regression. So I wanted to make a video and show you how to do that. But before I show you actually how to use JASP, I wanted to show you something that is in our Camino page. If you scroll down into the bottom of our modules, you'll see that there's additional resources, and one of them is a link to chapter summaries and PowerPoints and practice problems. These are all materials that are tied to the textbook, and you can see they're organized by chapter. So you can go there and you can download these things as supplemental materials. Then hopefully they're helpful to you. And the second thing is a data set. Now, this is a data set that has data from, I think, about 1,000 high school students that I collected some years ago. And you can download this data set and you can use it in JASP to analyze your own data, which is pretty useful. So what I'm going to do is I'm going to show you how to do that by opening up JASP and then going through and getting the data set and analyzing it by doing a multiple regression. So hopefully you've already downloaded JASP onto your computers. You open it up and you go to that open, and I've already opened this data set, so you'll see that's in my recent files. But if you haven't, click on computer, and wherever you have downloaded this data set to, go and find it. I downloaded it to my desktop, and when I open up my desktop, it shows up right there, right above my 2020 tax information. Don't forget, do your taxes. And if you open it up, it's just a spreadsheet full of data. You can see the variable names are up at the top, and then in the spreadsheet is just all the numbers from the data collected from these students. So that's not going to be all that useful to you just looking at all the numbers. They won't really make too much sense to you. But when you try and run an analysis, you can see it's a little simpler. So we're going to do a regression, a linear regression. So you click on that, and JASP opens up and it says, give me the variables that you want to analyze. So I'm going to look through my list of variables. These were all named by me, so I've got sort of a shorthand, which might be a bit confusing to you. But when we do some of this stuff during class, I'll explain the variables a bit more, and you can get an understanding of really what they mean. I'll explain a few of them for this example. So I think what I want to look at in this is, I think what we're going to look at is grades. Let me explain the grade variable that I use. I collected grades by getting students' grades in their English class, and then I coded grades on a 1 to 12 scale. So 12 is an A, 11 is an A minus, 10 is a B plus, 9 is a B, things like that. So let's make that the independent variable, and you'll see there's W numbers after some of the variables. That's because there's 4 waves of data that were collected, so the W number just refers to the wave. So I'm going to predict their English grade with 2 variables. One is self-handicapping, and self-handicapping is something that students do. It's really, we all do it, where when we feel like that we might not do well on some task or assignment, we might make up excuses so that if we don't do well, people won't think it's because we're dumb, they'll think it's for other reasons. So, for example, you might put off studying until the night before the test, or You might go out partying the night before a test so that if you fail, you can say, oh, it's not because I'm dumb, it's because I had a hangover. Or you might get involved in 200 different activities and join every club so that you make yourself so busy you've got an excuse if you don't do all that well in school. So that's what self-handicapping is. And we're going to use that to predict grades. That would be one predictor. So we're going to do a multiple regression. So we're going to pick a second predictor, and I'm using approach goals. Approach goals is the desire to do better than others, the goal of doing better than others. So it is defining success by outperforming others. And as you can see, as soon as I plug in those variables, it does the regression for me and produces the output. So I just clicked on that little arrow to make the output window bigger. And the first thing I look at is this R variable. R tells us what the correlation is between the predictor variables combined and the dependent variable, which was our English grade. And you can see that's a really small correlation. So these two predictor variables are not strongly correlated with the dependent variable, telling me that my multiple regression is not going to be super useful at this point. But nonetheless, we'll carry on. Over here, we get the R square, which is the amount of variance in the dependent variable that is explained by my two independent variables combined. And that is like 1/10 of 1%. So you can see these two predictor variables are very weakly related to the dependent variable, almost not related at all. So that's what R squared tells you, the variance explained in the dependent variable by the independent variables combined. The ANOVA tells you overall whether your model is statistically significant. So do the predictor variables combined, are they related to the dependent variable? And that p-value for the ANOVA was not significant, so the overall model is not significant. And then down here we get to see the intercept, which was about 8.9, just below a B. That's where the regression line crosses the y-axis. So when the two predictor variables are both at 0, the predicted value of y, English grade, would be 8.9. So a little bit less than a B. And because the two predictor variables are so weak, they're not really having much of an effect on the regression line. So that really tells us that our mean for our dependent variable is right around 8.9. When we look over at the two independent variables, we can see that the p-values for each of them are not significant. They are both very weakly related to the dependent variable. So we can see that really neither one of them is a significant predictor of the dependent variable. So self-handicapping does not predict grades in English, and neither does the desire to do better than other students. That doesn't predict either. Now, the power of multiple regression is it tells you, well, one of the benefits is it lets you compare the strength of the predictors in your model. So the standardized regression coefficients is another name for betas. So these are the betas. The betas, because they're standardized, can be compared directly to each other. So whichever variable has the bigger beta is going to be the stronger predictor of the dependent variable. As I mentioned, neither of these predictors is strong, neither is statistically significant, but you can see one is a little bit stronger than the other. So these results are not particularly impressive, but that's how you interpret a multiple regression in JASP. I'm just going to run one more quick multiple regression real quick, and that maybe has a little bit stronger results, and this isn't working because I accidentally clicked on logistic regression, which we're not going to do. That is a different kind of regression than we're going to get into. So let's do another linear regression. You can see our old variables are still there. We're going to click on them and move them back into the variable pool. And let's pick a new dependent variable. These are all sort of different kinds of motivation variables. So this one is family, and family is family orientation. So this is a desire to achieve in school for family reasons, including things like, I want to do well in school to make my family proud, or I want to do well in school so I can eventually be in a position to help my family financially. So these are really family concerns as motivators for doing well. And I'm going to see if that is predicted by self-efficacy. Self-efficacy is confidence in your ability to do well. So confidence in your ability to succeed is what self-efficacy is. And now let me pick a second predictor. I'll do self-regulation. Self-regulation are skills that students develop to regulate their own behavior. So these are things that keep you on task, organizing your material, time management, things like that. And as you can see, JASP has done the regression for me, and the R there is quite a bit bigger than the last one, so the two variables combined are correlated with the dependent variable, and the R square of about 0.8 says that about 8% of the variance in our dependent variable, which is family orientation, is explained by self-efficacy and self-regulation combined. All right, now, if we continue down, we look at the ANOVA results, and we can see that that is statistically significant. So that tells us overall, the two variables combined are related to or explaining variance in our dependent variable. If we look down here, we can see which of our predictor variables are statistically significant, and only one of them is. Self-regulation is highly statistically significant with a p-value of less than 0.05, and self-efficacy was not, with a p-value of greater than 0.05. Then when we go over here to look at the standardized regression coefficients, also known as the betas, we can see that self-regulation's got a strong, pretty strong beta, and self-efficacy does not. It's got a very weak beta. And you can also see that the beta for self-efficacy is negative, meaning that there's a small negative relationship between self-efficacy and family orientation, but a decently strong and significant relationship between self-regulation and family orientation. The beauty of multiple regression is you need to talk about the relationship between one predictor variable when controlling for the other. So in this case, we would say self-efficacy is not related to family orientation when controlling for self-regulation. But self-regulation is related to family orientation when controlling for self-efficacy. So remember, you're always talking about when controlling for the other predictor variables in the model. So hopefully that's helpful. That's how you do it.